Hello, I am Dr. Srutishrabha Bharali and I welcome you all to this lecture video on functions in Python, which is a part of the online course on open source software for academia. Functions are one of the most essential building blocks in any programming language, and Python is no exception. In this video lecture, we delve into the core concepts of functions to understand how they work and how they can be effectively used in Python programming. In this video lecture, we will learn about the two main categories of functions in Python: built-in functions, which are provided by Python itself, and user-defined functions, which can be created to suit our specific needs. We will demonstrate how to define a function, call a function, and return values from the function using practical and easy to follow examples. We will also discuss additional features such as the exit function and default arguments, which give functions more flexibility by allowing parameters to have default values. Furthermore, we will explore how to pass a group of elements to a function, which enables us to handle multiple values efficiently. In addition to covering regular functions, the lecture takes a deeper dive into the powerful concept of recursion. Recursion occurs when a function calls itself, either directly or indirectly, and is often used to solve complex problems by breaking them down into simpler sub-problems. In this video, we explain recursion using clear examples that demonstrate how and when to use recursive functions in Python. By the end of this lecture, you will gain a strong understanding of both standard and recursive functions. You will be able to define your own functions, work with arguments, and return values, and apply recursion effectively in Python. The foundational knowledge is crucial for writing clean, efficient, and reusable code, and it will serve as a stepping stone for more advanced programming concepts in the future.
A function is a well-defined block of code consisting of a group of statements that work together to accomplish a particular task. Functions are designed to carry out specific operations, making the code more organized, reusable, and easier to manage. When a program needs to perform multiple tasks, instead of writing all the instructions in one place, we can create separate functions for each individual task. This approach not only enhances clarity and structure but also simplifies debugging and maintenance. By dividing a large program into smaller manageable functions, each responsible for a distinct operations, we make the overall program more modular and efficient. Functions in Python can be broadly classified into two categories: built-in functions and user-defined functions. Built-in functions are those that come predefined and readily available as part of the Python programming language. These functions are developed by the creators of Python and are included in the standard library to help programmers perform common tasks without having to write code from scratch. For example, square root or sqrt function, which is used to calculate the square root of a number, is a part of the Python's built-in function. Other examples include len function for the length of a string or list, input function to get input from a user, and print function to display the output on the screen. Let us look at an example for built-in functions. This program demonstrates the use of built-in functions in Python. It takes a sentence as input and uses the inbuilt len function to find its length, and inbuilt type function to display the data type of the variable sent. It then takes a number as input and it converts it to an integer using inbuilt function int and displays its data using type function.
User-defined functions are those that are created by programmers to perform specific tasks according to specific needs. These functions allow developers to structure their code in a clean, logical, and modular way. Instead of repeating the same code multiple times, a user defined function can be written once and then called whenever needed. This enhances code reusability and readability. By defining custom functions, programmers can tailor their programs to handle unique problems and operations that are not covered by Python's built in functions.
The syntax for defining a function is shown in this slide. In Python, a function is created using the def keyword, followed by the function name and a pair of parentheses. This parenthesis may include 0, 1, or multiple parameters, which act as variables that receive input values when the function is called. Immediately after the parenthesis, a colon is used to indicate the beginning of the function body. The function body consists of one or more indented statements collectively referred to as a suit. Typically, the first line within the function body is a docstring, which is a descriptive string enclosed in triple single quotes or triple double quotes and is used to explain what the function does. This docstring is optional and can be either a single line or may span multiple lines. After the docstring, the actual logic or operations of the function are written as part of the function's main code block. Let us look at an example of function. In this example, the def keyword indicates the beginning of a function definition. The function is named even odd followed by parentheses that contain a single parameter num and ending with a colon to mark the start of the function body. A docstring is provided using triple single quotes describing that the function is designed to determine whether a given number is even or odd. The main logic follows the docstring. It checks if the number is divisible by 2 and if true, it is identified as even. Otherwise, it is classified as odd. After defining a function, it must be called in order to execute as functions do not automatically run on their own. To call a function, we simply write its name followed by parentheses containing the required arguments or values for its parameters. For instance, to call the even odd function with the number 4 as an argument, we will write even odd and within parentheses the number 4. When this statement is executed, the Python interpreter transfers control to the function definition and assigns the value 4 to the parameter num. The function then processes this value using the statements within its body to produce the desired result. The data or values provided to a function during function call are known as arguments. In this program, the even odd function is called twice. During the first call, the value 4 is passed as an argument and the output confirms that it is an even number. In the second call, the value 7 is provided and the result correctly identifies it as an odd number. We can return the result or the output from a function using the return statement. This program demonstrates how to return a result from a function in Python. The function add takes two parameters, adds them, and returns the result using the return statement. A docstring is included to describe the purpose of the function. The function is called twice, first with two integers, 25 and 50, and then with two floating point numbers, 25.3, and 50.7. And the returned sums are stored in variables a and b, which are then printed. In this example, during program execution, the variables num1 and num2 can hold values of any data type, such as integer or floating point. This behavior is known as dynamic typing, where the data type of a variable is determined at runtime rather than being explicitly declared beforehand. Let us look at another example, this time to find a factorial of a number. This program defines a function named fact that calculates the factorial of a given number. The function takes one parameter num and initializes a variable f to 1. It then uses a while loop to multiply f by each number from num down to 1. Once the loop ends, the final value of f, which is the factorial, is returned. The function is called after taking user input, which is then converted to an integer. The result is then printed on the screen. In this case, we have entered the number 4, so the program calculated and displayed the factorial of 4, which is 25. In Python, a function can return multiple values using a single return statement. Unlike some programming languages that allow only one value to be returned at a time, Python supports returning several values at once. This makes Python functions more flexible and powerful. When a return statement contains more than one value separated by commas, Python automatically groups those values into a tuple and returns it. The caller can then unpack the tuple into individual variables or access each value using indexing. This feature is especially useful when a function needs to perform multiple related calculations and send all results back to the caller. It improves code readability, reduces redundancy, and allows for cleaner function design. Let us now look at an example. This program defines a function addSub that returns two results, the sum and the difference of two input numbers. Inside the function, it calculates the sum as sum equal to num1 plus num2 and the difference as sub equal to num1 minus num2, and then returns both values as a tuple. When the function is called with addSub within bracket 100, 50, the returned values are unpacked into variables a and b, which are then printed. This demonstrates how a Python function can return and use multiple values simultaneously. Let us look at another example. This program demonstrates how a function in Python can return multiple values. The function calc takes two numbers as input and performs four operations: addition, subtraction, multiplication, and division. It then returns all four results as a tuple. The docstring is also included in the function to describe the purpose of the function. When the function is called with the arguments 40 and 20, the returned results are stored in the variable c. The individual results are accessed using indexing from C0 to C3 and reprinted to display the outcomes of each operation. This program highlights how Python allows functions to return more than one value at a time. By grouping multiple outputs together, it simplifies the process of returning and managing several results from a single function call. This approach is useful when multiple related computations are performed on the same set of inputs. The exit function in Python is used to immediately terminate the execution of a program. When called, it stops all further code execution regardless of where it is used, including a function. This can be helpful in the context of functions when an error or invalid input occurs and we want to stop the program instead of continuing. or when we reach a condition where the continuing execution no longer makes sense, or even when designing an interactive script and we want to allow the user to exit gracefully. The exit function is provided by the sys module. So we need to first import sys module and then call sys.exit function. Let us look at a program where we use exit function. The program starts by importing the sys module. Then the function divide with two parameters num1 and num2 checks whether the denominator num2 is 0. If num2 is equal to 0, then it prints an error message and calls sys.exit function to terminate the program immediately, skipping any code after that. But if the values are valid, it proceeds to perform the division and returns the result, which is then printed. In the output, we can see that for the first case, when the numerator is 10 and the denominator is 2, it performs the division and the output of the division is printed on the screen, which is 5. In the second case, when the numerator is 45 and the denominator is 0, it displays the error message and then uses sys.exit function to terminate the program immediately. In Python, it is possible to assign default variables to function parameters directly within the function definition. This means that if a value for such a parameter is not provided when the function is called, the default value will automatically be used. This feature makes functions more flexible and convenient, especially when we want certain parameters to have common or assumed values unless specifically changed by the user. Default parameters are defined by assigning a value to the parameter in the function header using the assignment operator. Let us take an example to understand how we can use default arguments. This program demonstrates the use of default arguments in a Python function. The function power is defined to take two parameters, base and exponent, where exponent has a default value of 2. If the caller does not provide the second argument, the default value is used and the base is squared. In the output, in the first case, when the function is called, only the base is given, so the default exponent 2 is used. In the second case, when both base and exponent are provided, the custom exponent 3 is used for calculation, as can be seen in the output. To pass a group of elements to a function, we can first store them in a list and then pass that list as an argument to the function. Inside the function, the list can be processed as needed, allowing us to handle multiple values efficiently using a single parameter. This approach is useful for performing operations on groups of related data. Let us look at an example. This program demonstrates how to send multiple elements to a function using a list. The function greatest with parameter numbers accepts the list of numbers and returns the largest number from that list. It starts by assuming that the first number is the greatest and then iterates through the list, updating the greatest value when it finds a larger number. In the main part of the program, a list G1 containing 5 numbers 45, 76, 23, 91 and 61 is passed to the function. The result is then printed displaying the greatest number in the list, which is 91 in this case. Let us now look at another important concept, which is recursion. A recursive function is a special type of function in programming that calls itself repeatedly during its execution. This process continues until a specific condition known as the base case is met. The base case acts as a stopping point to prevent the function from calling itself indefinitely. In each recursive call, the function typically works on a smaller, or simpler version of the original problem, gradually moving towards the base case. Recursion is often used to solve problems that can be broken down into smaller, similar subproblems, such as calculating factorials, traversing trees, or solving mathematical puzzles like the Towers of Hanoi. Recursive functions should include base case. It is the condition that ends the recursion, and recursive case, which is the part where the function calls itself with modified arguments. First, let us see how we can calculate the factorial of a number using recursion. For example, we can write that factorial of 3 is 3 into factorial of 2. Similarly, factorial of 2 is 2 into factorial 1. Again, factorial of 1 is equal to 1 into factorial of 0. And we know that factorial of 0 is 1. So, all the preceding statements will evaluate as factorial of 1 is equal to 1 into 1, which gives us 1. Factorial of 2, which is 2 into 1, gives us 2. And factorial of 3, which is 3 into 2, which gives us 6. So, we can write the formula for factorial as factorial of n is equal to n into factorial of n minus 1. Let us look at an example. This program demonstrates how to calculate the factorial of a number using recursion in Python. The function fact calculates the factorial of a number. It uses a recursive approach where the function calls itself with a smaller number each time. In the base case, when the input number is 0, the function returns 1. This acts as a stopping condition for the recursion because by definition, the factorial of 0 is 1. In the recursive case, for numbers greater than 0, the function returns the product of the number and the factorial of the number just before it. During the function call, the user is asked to input a number. This input value is then passed to the function and the returned result is stored in the variable f. Finally, the value of the variable f displayed using the print statement. For example, when we give the number 5, we see that the factorial returned is 120. Let us now see how we can use recursion to generate Fibonacci numbers. Fibonacci numbers are a sequence of numbers in which each number is the sum of the two preceding ones, starting from 0 and 1. So the first number is 0 and the second number is 1. Every number after that is the sum of the previous two numbers. So the next number will be 0 plus 1, which is 1. For any number n in the sequence, f of 0 is 0, f of 1 is 1, and when we want to find the nth Fibonacci number, we will find f of n minus 1 plus f of n minus 2. This is for all n that is greater than equal to 2. This program generates Fibonacci numbers using recursion. The function Fibonacci with parameter n returns the nth Fibonacci number. It has two base cases. It returns 0 when n is 0 and 1 when n is 1. For all other values, it recursively calls itself to return the sum of the two preceding Fibonacci numbers. The user is prompted to enter how many Fibonacci numbers they want. For loop is then used to print that many Fibonacci numbers starting from 0. When the user gives input as 10, the program prints the first 10 Fibonacci numbers starting from 0. This means that the for loop runs from 0 to 9, that is 10 times, calling Fibonacci I, that is the ith number, in each iteration and prints the result. So first we will get Fibonacci of 0, then Fibonacci of 1, and this goes on till Fibonacci of 9 to get the 10th Fibonacci number. Finally, the list of the first 10 Fibonacci numbers are generated using recursion and displayed as result. Let us look at another example. This program is a simple and clear example of recursion. The function sum of digits recursively calculates the sum of the digits of a number n. N modulus of 10 gives us the last digit of the number. N divided by 10 removes the last digit from the number. Here we use two slashes in n divided by 10 instead of one slash, because when we use two slashes, it performs integer division, which removes the last digit of an integer, while single slash would perform floating point division and result in a decimal, which is not useful in this case. This recursion continues until n becomes 0. Each call processes one digit and passes the remaining number to the next recursive call. So, first of all, here we can see that we have passed the whole number 1, 2, 3, 4 to the function sum of digits. Now, 1, 2, 3, 4 modulus of 10 returns the number 4, and 1, 2, 3, 4 divided by 10 gives us the number 123. Now, the remaining number is again passed to the function sum of digits. Now, this goes on till the number becomes 0. Once the number becomes 0, the recursion stops and the sum is calculated as the call start unwinds. Here we can see that when we add all of these values, we get the final summation value, which is 10. Let's take a moment to access your understanding with a couple of quick multiple choice questions. This will help you review and reinforce what we have covered in this tutorial. Here is the first question. Which line below correctly defines a function that takes two parameters? Take a moment to think about your answer. The correct answer is option A. Here is the next question. Which of the following is used to provide a brief explanation about a function? Take a moment to think about your answer. The correct answer is option B, docstring. Here is the next question. What is the purpose of sys.exit in a Python function? Take a moment to think about your answer. The correct answer is option D, to terminate the program immediately. Here is the next question. What will power of 5 return if the function power is defined with default argument as given in the slide? Take a moment to think about your answer. The correct answer is option C, which is 25. Let us look at the next question. What symbol is used at the end of the function header in Python? Take a moment to think about your answer. The correct answer is option C. Let us look at the next question. What is the purpose of a base case in recursion? Take a moment to think about your answer. The correct answer is option B, to stop further recursive calls. If you got all the answers right, good job. If not, don't worry. You can revisit the explanation in the video.
This lecture video provided a comprehensive explanation of how functions are defined and invoked in Python programming. At the onset, the video began by introducing the basic structure and syntax used to create functions, making it easy to understand how to write and call functions effectively. The video also distinguished between built-in functions, those that are readily available in Python, and user-defined functions, which are created by the programmer to perform specific tasks.
These concepts were reinforced through a variety of clear and practical examples, helping to illustrate their use in real coding scenarios.
Furthermore, the lecture delved into the concept of recursion, explaining how a function can call itself to solve problems that can be broken down into smaller, similar subproblems. Thank you for watching this video.